Hello, everybody. Welcome back. Mr. Anderson here with you. Another edition of geometry. Hey, today I'm wearing my Hog Wild t-shirt. Arkansas Blood Institute just gave some blood the other day, so I got this t-shirt. Anyway, I don't know what that's got to do with parallelograms, but we're going to talk about parallelograms today. Okay, section 6.2. Let's see what we're going to do today. We're going to recognize and apply properties of the sides and angles of parallelograms, and then recognize and apply properties of the diagonals of parallelograms. Okay? All right, first of all, the definition of a parallelogram. What is a parallelogram? All right, a parallelogram is a quadrilateral with both pairs of opposite sides parallel, hence the name parallelogram. Okay, so both sides are parallel. What does that look like? Here's what it looks like. This is a parallelogram. You notice this and this are marked as being parallel with one arrow, and then this and this are marked as being parallel as well with two arrows. So both sides of the quadrilateral are parallel, so that makes it a parallelogram. Okay, I don't know what that was. The symbol for this, it just looks like this parallelogram, but kind of smaller. You could say, you could make this little, if it'll let me do it, kind of a little parallelogram like that. So I could call this parallelogram A, B, C, D. It's not critical. You're going to see this a lot of times, people not using that symbol and just calling it A, B, C, D. Remember, just follow the rules that if you're naming a quadrilateral, in this case a parallelogram, just go in order around the edge. So A to B to C to D. If you just say A, B, C, D, that's also fine. All right, so here's some properties of parallelograms that we're going to need to know today. First of all, if a quadrilateral is a parallelogram, the opposite sides are congruent. Okay, so that's one of the first things. We know the opposite sides are parallel, but what's going to happen in a parallelogram as well as the opposite sides are also going to be congruent. So, you know, if these two, let's say if this top and the bottom one are parallel, in order for these two side ones to also be parallel, they have to be the same distance, because if this one's a little bit longer, then these two won't be parallel as well. So this has to happen as well in a parallelogram. Opposite sides are congruent. Second thing here is, and I've broken this up into two parts, that's why this is part one, because it was kind of hard to see when I put all this on one page. The opposite angles are also congruent. So in this example here, you can notice that angle J and angle L are marked as being congruent, and then K and M are congruent. And so that's also going to happen in a parallelogram. All right, part two. Now you notice here on this one here says consecutive angles are supplementary. So remember, consecutive angles mean angles that are right next to each other, and supplementary, remember, means it equals 180 degrees. Okay, so remember, this is 180 degrees, and consecutive angles are right next to each other. So you notice in this little diagram here, it's marked as the angles across from each other are the same. They're congruent, x and x, y and y. But also what's got to happen is anything that's right next to each other, any combination of x plus y, this x plus that y, or that x plus that y, will always equal 180. All right, and so these, if you remember here, that with parallel lines, these would be the same things as consecutive interior angles. Remember when we talked about that at the beginning of the year, and they equal 180. So it's the same thing that we did at the beginning of the year, except for now it's in a parallelogram, not just two parallel lines. Okay, and then finally here, this is a rectangle. A rectangle is a certain type of parallelogram that has a right angle, and all this says is, hey, if you have one right angle, then they all have to be right angles. And if you think about that, you say, hey, if this is a parallelogram, across from angle J has to be the same. That has to be a right angle. And if the two next to each other have to add up to be 180 and one is 90, well, this also has to be 90. So in other words, they all have to be 90. Okay? All right, let's do a few problems here. All right, ABCD is a parallelogram. We want to find AB. Well, here's AB right here. And so we say, well, that's a side. Well, what do we know about the sides? Well, the opposite sides are congruent. So we say, well, if I want AB, I just look to the opposite side. That's 30. So it looks like the answer should be 30, and yes, it is. Okay, so AB over here would also be 30, just like this side over here. All right, how about angle C? Well, now angle C, we're looking at an angle, not a side. So we're looking at this angle up here. And we say, well, what do we know about the angles? Remember, the angles that are straight across from each other are congruent. So if this one's 36, then this also has to be 36 degrees up here. So it looks like that would be A, and it is. Okay, how about this one? Angle D. Well, now angle D is down here. So now we're saying, ooh, okay, what do I do here? I don't have anything across from it to make it equal to. But what I do know is, I do know this 36, and I know any two angles that are consecutive right next to each other, they have to equal 180 degrees, right? So in other words, we're just going to call angle D x. So if I just take x plus 36, that has to equal 180. So I can just then subtract 36, right? And then I'll find out what angle D is, and in this case, it's what? 144. And so it looks like this would be 144 degrees, and that's C, and yes, the bouncing red circle says 144. All right, good. Hopefully getting a feel for that. Well, what if it gets a little bit more complicated? Ooh, look at X's and Y's. This is getting really tricky. Okay, we're going to try to find X and Y. Well, let's just start with X, and we say, well, here's our X down here. What do we know? That's the angle. It's 2x minus 1 degrees. It's angle A. So what do I know? Well, I know that the angles straight across, opposite from that, are going to be equal. So I look straight across over here. That's 75. So what's my equation that I'm going to write? I'm going to say 2x minus 1 has to equal 75. I'm just going to solve that now. So plus 1. So 2x equals 76. And then divide by 2. And so x equals 38. Okay? So we know that x has to be 38. All right. Ooh, okay. What about y? Well, if you look over here, here's y minus 4. Well, that's a side. That's side AD. Well, we know in a parallelogram that the side straight across from that or opposite to that is congruent, and so that's 11. So our equation there for y is y minus 4 equals 11, and all we have to do is add 4. So y equals 15. Okay? Kind of starting to get a feel for this, hopefully. All right, how about this one? Okay, find the value of x. Well, it's here, but if I look across, there's nothing I can make it equal to over here. What can I do? Well, here's an x. Ooh, but across from that one, there's nothing I can make it equal to there either. Well, what else can I do? Remember the other thing with parallelograms, that two consecutive angles, which these are, have to add up to be 180 degrees. Okay, so why don't we just say that 5x plus 11x plus 4, if we add those together, it has to equal 180 degrees. And now we're going to solve that one. So 5x and 11x is 16x. And then we subtract 4. So 16x equals 176. And then we divide by 16. And we end up with 11. So x equals 11. And if you wanted to check that, you could just put 11 back in here to find that that's 55, put 11 in here, And you're going to get what? 121 plus 4, that's 125. Is 125 and 55 equal to 180? Yes, it is. So we're good. Okay, so that's how you can check yourself. Okay, now the diagonals. All right, diagonals of parallelograms. In this first one here, we say the diagonals bisect each other. Okay, remember bisect means to split it exactly in half. Okay, so the diagonal, remember, is from the one vertex to the opposite vertex. So from A to C is a diagonal, and from B to D is a diagonal. And so where they cross, where those two lines cross, that splits this AP and PC into two equal parts. So they don't have it marked here, they just have the outside edges marked. But what I'm going to do here is I'm going to mark, and then of course DP and BP are the same too. So I'm going to mark this as with 3 marks, since they've already used 1 and 2. So BP is congruent to DP. That's what they said right here. And then also 1, 2, 3, 4. 1, 2, 3, 4. And then AP is also congruent to PC. Whew. Somehow that's hard to say today. Okay, so the diagonals, when they split each other into two, what am I trying to say here? Okay, when you have the diagonals, they're going to split each other into two equal parts, bisecting. Okay, keep that in mind, and notice well, maybe that's the next session. We're going to talk about that. We're going to talk about that midpoint spot right there. So just keep in mind that this spot right here where they cross is the midpoint of both lines. Okay, that's going to come up again. All right, and then in the second part here, if it's a parallelogram, the diagonal makes two congruent triangles. If you just draw one diagonal, these two triangles are congruent. And if you remember when we were talking about side, angle, side, 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 angle, side, angle, 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 side, those things about telling if triangles are congruent. Well, if you notice here, this is a parallelogram. So the opposite sides, like AB is congruent to DC, AD is congruent to BC, and then since these two smaller triangles share this side, that has to be congruent to itself. So notice side, 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 side. By side, 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 angle congruency, those two are congruent. So that might be something that you could use as well in a parallelogram. Okay, so wow, lots of stuff going on here. Let's see what we can do. First of all, we're going to try to find x. All right, well, where's x? If we look, here's an x, and here's an x. No other x's anywhere else. Well, 4x plus 12 is this part of the diagonal, and 6x plus 2 is this part of the diagonal. Hey, those two should be the same, right? Because this is a diagonal, and it splits this into two equal pieces. So what we're going to do here is 6x plus 2 has to equal 4x plus 12. Minus 4x. Minus 2. So 2x equals 10. Divide by 2, x is 5. All right, so it looks like that should be answer C. Bouncing red circle says yes, it's C. All right, good. So the whole key there was that the diagonal got bisected by the other diagonal, and so they are two equal parts. All right, what about if we want to find now the value of P? Well, where's P in this one? Okay, here's 2P. Now there's no other P's around here, so what do we know? This 2P is side AB. What do we know about the sides? The opposite sides are congruent. So what's opposite from side AB is side DC, which is 22. So the equation we're going to write there is 2P equals 22. And then, of course, to solve that, we just divide by 2. And it looks like P is 11. And so that should be answer D. Bouncing red circle, please show us that it's 11. Yes, good. Okay, so that's 11. All right. How about this one now? What about K? A little bit trickier here on this one to find the value of k. Well, where's a k? Here's, first of all, here we go up here. There's 3k plus 4. That's talking about this little angle right here. Well, what do I do with that? Now remember, there's two ways that you could look at this. We just talked about congruent triangles, and so you could look at it that way and think about ABC as a triangle, and then ADC as a triangle, and then see what angle does this 3k plus 4 match up with in the other triangle. And you might be able to do that. You're going to have kind of have to spin that around in your head, or make marks there to show what sides are congruent. But keep this in mind. Here's another thing to think about. What about this? Remember way back at the beginning of the year, we talked about parallel lines, which AB and DC are, and a line that cuts through them, a transversal. Remember, one thing that we learned was that alternate interior angles are congruent. Hey, so you know what? If we think about it that way, 3k plus 4, this angle, what's the alternate interior angle compared to the 3k plus 4? It's this one down here. So those two angles have to be congruent. So 3k plus 4 and 25. So our equation here could be 3k plus 4 equals 25. We subtract 4. 3k equals 21. Divide by 3. And so it looks like k should equal 7. Is that one of our answers? Sure is. It looks like it's D. And that's correct. D is answer. Letter D, which is K. Oh, you know, IDK, is correct. All right, so last example here. We're talking about coordinate geometry. Basically, this is just we're using the coordinate plane, which remember has an x-axis and a y-axis, and we're plotting the points here. So we're going to find where the diagonals intersect. Okay, so remember they bisect each other, so we're going to see where that spot is. That's the midpoint of each of those diagonals. So let's graph these first of all. Negative 3, 0 is right there. And then negative 1, 3, somewhere about there. 5, 4 is right here. And then 3, 1 is right there. Okay, so those are the vertices. So let me draw the edges there. All right, so that's the parallelogram that we're talking about, okay? So, but what we want to do is we want to look at the diagonals. So what I'm going to do is I'm going to change this to a different color. I'm going to go with a blue, a dark blue. And so remember the diagonal is connecting the opposite vertices here. So I'm going to connect those two vertices. Okay, so what we're going to do is we're going to say, well, it looks like where they cross, remember where they cross is right here. It's kind of hard to tell exactly what that is, especially since I'm trying to draw this by hand here and it's not perfect. How can we figure out that exact spot? Well, if you recall, these two diagonals, they bisect each other. So the place where they cross is the midpoint of each of those lines. So this is the midpoint of both of those lines. So if I can find the midpoint of these two lines, that's where that spot is going to be that they're going to cross. Well, fortunately, we have done something before that we have done the midpoint formula before. We have a formula for that, right? So the midpoint, boy, this is being really picky today. So the midpoint formula, actually, here's what we have to do is figure out what points to do the midpoint from. So we're going to do a midpoint from negative 3, 0 and 5, 4. So we're going to, first of all, do a midpoint between those two. Okay, so we're going to do the midpoint of M and P. Okay, so remember how we do the midpoint there? We do we add the x's first of all, so negative 3 plus 5, and then divide by 2. And that's going to be, actually here I'm going to keep this as an ordered pair. That's the x value, and then the y value is going to be what? 0 plus 4 divided by 2. So altogether the midpoint is what? 5 minus 3 is 2. 2 divided by 2 is 1. And then 0 plus 4 is 4. 4 divided by 2 is 2. So it looks like the midpoint of MP is 1, 2, which is pretty close to where I've got it here. It looks like it's at 1, 2. Now that, if we are sure that this is a parallelogram, that would be great. But what we're going to do is we're going to do one more midpoint. The midpoint of what? The other one, which is negative 1, 3. So we're going to do the midpoint of N and R. Just to double check, what should happen is it should have the same midpoint, right? It should be this exact same thing. So let's do that. So again, we're going to add the x's. So 3, I'll do the negative 1 plus 3. I'll do it that way. Divided by 2. Oops, sorry. And then 3 plus 1 divided by 2. So this 3 minus 1 is 2. 2 divided by 2 is 1. 3 plus 1 is 4. Divided by 2 is 2. Guess what? It's the exact same thing. Okay? And so that shows the coordinates of where they cross. And that kind of proves, and we're going to talk about this a lot in 6.3, that proves that this really is a parallelogram because those two diagonals cross in the exact same spot. All right, awesome. That's it for today. Appreciate you being here. This is Mr. Anderson signing off saying, go hog wild.